let's come to today's lecture on forms of energy and energy conversions. So with Newton's laws of motion that we had earlier in the course, overcoming the misconceptions that everybody have, this is enough to understand motion, to deal with motion, and to predict motion. That's what the engineers learn in school to build houses, bridges, rockets, and so on. So motion includes also zero motion, static of houses, bridges, and the motion of rockets, satellites, and all that. So there is another quantity that is one step beyond, and that's the concept of energy. It's a little bit more abstract than Newton's laws, but it has many advantages. One of the reasons is because it reaches in all parts of physics, in the physics of motion, in the physics of electricity, of heat, and other things. And today I want to give an overview of different forms of energy. So people always prick up their ears when it comes to money, so I want to capitalize on that. Money also comes in different forms, like energy. So I have a few forms of money. Here's a dollar bill. Right above, I have 4 quarters. Which buys more, the dollar bill, the paper bill, or the 4 quarters? Buys the same. Okay? These are different forms of money, but they are worth exactly the same. So I have another dollar. That's a brown one. And the Queen of England is in front. And on the back is an exotic bird because it's a New Zealand dollar. Then I have another coin that also has the Queen of England. And the kangaroo hops across in front, Australian dollar. So these are different forms of money. With money, there are the exchange rates. In physics, it's even simpler. The exchange rate is always the same for the different forms of money, forms of energy. And here are 100 yen. That's roughly also worth $1. Different forms of money, different forms of forms of energy. So in these, just like money can be converted from one currency to the other, so the forms of energy can be converted. And let's start with the first one. Make your hands free. Put your pencil down and put them together with 10 newtons. Squeeze them together with 10 newtons and move them with 1 meter per second, 2 miles per hour. Ready, set, go. Okay, a little bit faster there. Now we are converting energy of motion to what? So as we go along, we'll fill in. So this was already the first energy conversion. So on top is from, and down is to. So that was energy of motion to thermal energy. Rubbing, friction. That was easy. Now the opposite is not quite as easy. That takes a little bit longer, where we convert thermal energy to energy of motion. So that was achieved only about 200 years ago, but it has changed the world, has spawned the Industrial Revolution, the steam engine. We'll have another lecture later in the course, so I'll show it briefly today. So here's a gas burner that provides the thermal energy. Actually got ahead of myself. The steam engine that I'll show, you'll build the same one in the last lab in this course. So to prepare you for that, you need to bring 2 soda cans on that day and scissors, and then you'll cut the soda can in a certain way, cut the lid off so that you have the can like this, and from the other can you cut the bottom off and connect that with a cork, and that provides a lid for this can, and that lid needs to be sealed, but prior to that, you puncture holes in the side. In the holes, not so that the steam comes out this way, but at a tangent. That provides a turning motion called torque. Okay, so, and also prior to sealing, you'll put in a little bit of water. And you even can build your own V8 engine if you want. In this course, the lab. So let's see. So you can hear it sloshing. There's a little bit of water inside. I hold that over the flame. It'll take a while until the water boils and produces steam. So need to wait a little bit. But once water boils, I can hear from the hissing sound. There's another energy conversion going on inside. Now I hear the hissing sound. That's a steam engine. Why does it rotate so long? Rotational inertia. Okay, so many things coming back. So keep in mind that's the opposite of rubbing. So from thermal energy to motion. So let's fill that in our chart. Where will that be? From thermal energy to motion. That's a steam engine. There's an energy conversion going on the table here. From what to what? So the candle burns what? The wax of the candlestick. That's a certain chemical. So here's a little hint. From which form of energy? From chemical energy to what? From chemical energy to thermal energy that gives the warmth, and also to light energy that gives the flame. Another energy conversion coming up, the flashlight. That is to light, but from what? From electric energy. And you'll fill that in a moment. And where does the electricity come from? So I just took the batteries out. And where does the electricity come from? From the batteries. What's going on in the batteries? There's a chemical reaction going on inside, and that produces the electricity. So let's fill that in. From chemical energy. So when we use a battery, that's from chemical to electric. And then from electric to light energy, that's a lamp.